Hello everyone. In this session, we will learn about the concept of NP-hard and NP-complete problem and non-deterministic algorithm. This is the chapter of computer algorithm, and let us see the basic concepts of NP-hard and NP-complete problem. So, before moving with an NP problem, let us distinguish between the problems that can be solved by polynomial time algorithm and problems for which no polynomial time algorithm is known. So, it is an unexplained phenomena that for many of the problem we know and study, the best algorithm for their solution have computing times that cluster into two groups. The first group consists of problem whose solution times are bounded by polynomial of some small degree. For example, we have seen in the book included order searching, polynomial evaluation. And the second gap is made up of problem whose best known algorithm are non-polynomial. So the theory of NP completeness which we present here does not provide a method of obtaining polynomial time algorithm for algorithm in second group. So let us see the problem of what is NP problem. So basically the NP stands for non-polynomial, where the problem is a set of problems whose solutions are hard to find but easy to verify and solved by non-deterministic machine in polynomial time. So here there is a problem of NP hard and NP complete. The problem that is NP complete has the property that it can be solved in polynomial time if and only if all other NP complete problem can be solved in polynomial time. So this is the concept of NP complete. Now in NP hard, any decision problem Pi is called NP hard if and only if every problem of NP is reducible to Pi in polynomial time. And NP complete is any problem in NP complete if it is a part of both NP and NP hard problem. So although all NP complete problems are NP hard, but some NP hard problems are not known to be an NP complete. So the problem that is NP complete has the property that it can be solved in polynomial time if and only if all other NP complete problems can be solved in polynomial time. And if NP hard problem can be solved in polynomial time, then all NP complete problem can be solved in polynomial time. Remember, this is very important to understand the concepts of NP hard and NP complete, because we will be seeing the classes of NP problem in further session. So all NP complete problems are NP hard, and but some NP hard problems are not known to be an NP complete. So although one can define many distinct problems classes having the properties stated above for the NP hard and NP complete classes, then the classes we study are related to non-deterministic computation. We will be seeing what is non-deterministic algorithm, but for until now a problem that can be known in polynomial time algorithm and computation is an NP problem. So to solve these types of NP problem, we have to see what is NP hard and NP complete problem. We all know now what is NP hard and NP complete problem. So we see that the class of NP hard problem is very rich, as it contains many interesting problems from a wide variety of discipline. So now let us discuss about what is non-deterministic algorithm. So up to now the notion of algorithm that we have been using has the property that the result of every operation is uniquely defined. So if the result of every operation is uniquely defined, then algorithm with this property are termed as deterministic algorithm. So basically it is stated as a non-deterministic algorithm can provide different outputs for the same input on different execution. So unlike a deterministic algorithm which provides or which produces only a single output for the same input even on different runs, a non-deterministic algorithm travels in various routes to arrive different outcome. But remember that in non-deterministic algorithm every output should uniquely define, that every operation has some unique output, and if such is an algorithm we will be termed as an deterministic algorithm. So now In a theoretical framework, we can remove these restrictions on the outcome of every operation. We can allow algorithm to contain operation whose outcomes are not uniquely defined but are limited to a specified set of possibilities. And the machine execution such operation is allowed to choose any one of these outcomes subjected to a termination condition. We will define it in later. So this leads to a concept of non-deterministic algorithm. And in non-deterministic algorithm, to specify such algorithm, we introduce three functions, and those three functions are choice, failure, and success. Now let us see what are these three functions. The first is choice. Now the arbitrary chooses one of the element of set S. Now there is a set S and we will be choosing any of the one element between that set S. Then it will be considered as a choice. Next is failure. Now there is an unsuccessful completion. Then if there is unsuccessful completion, we will be termed as failure. And if there is a successful completion, that is signals has a successful completion, then it will be turned as an success. Now let us see with an example of non-deterministic search algorithm. Now suppose the assignment statement X has choice 1 to n and could result in X being assigned any one of the integer in the range of 1 to n. Now in that case there is no rule specifying how these choices is to be made, but the failure and success signals are used to define a computation of an algorithm. Now here in this case of non-deterministic search algorithm, consider the problem of search for an element X in a given set of element a 1 to n and n is greater than 1. So we require to determine an index j such that if there is present in x is present in a of j or j is 0, then x is not in a. Now suppose here we have a choices of 1 to n, like we have a set of 1 to n, and in that 1 to n we have to search whether the x is present or not. So we denote variable j that contains choices 1 to n, that is it has a set of 1 to n. Now if a of j, that is array of j, in an array of j there is a variable x is a variable which we have to be searched. Now in that set, if suppose x is present in array of j, then we will write j and give a status as success. If in array of j x is not present, or if we doesn't found x variable, then we will write the status as failure. Now here in this case there is present a of j is present, hence we have wrote write j and success, else we will be writing write 0 and failure. So this is the concept of non-deterministic search algorithm. For example, let us take there is 1 to 10 elements, a set of 1 to 10 elements, and that 1 to 10 elements are stored in array of j, and we have to search element number 7. Now in 1 to 10 we know 7 is present. Now if 7 is present in array of j, we will write the status as write j and success. If we took another number like 17 and we know that 17 is not present in 1 to 10 set, then we will write 0 and give the status as failure. So this is non-deterministic search algorithm. Let us see non-deterministic sorting algorithm. We have seen searching algorithm. Now let us see non-deterministic sorting algorithm. As we all know, in the concept of sorting, we have to sort the element in either in ascending order or in descending order. Here in this case we will be sorting the elements into an ascending order. So now let us see non-deterministic algorithm for a sorting problem. Now let us take an variables like a to n, and we have to sort n positive integers. Now in this case we have n variables. So for I 1 to n, b of I will be 0. We have initialized one b variable as a temporary variable, and there is a array of 1 to n stored into an I variable. So we will give a choice to 1 to n variable which is stored in a j variable. Now j contains 1 to n set. Now if b of j is not equal to 0, like b of j is not equal to 0, then we will write a status as failure. And if there is an element which we have to sort between first element and then second element, if there are two elements, then b of j is equal to a of I. Now to verify the order, again we will consider an subset like I is equal to 1 to n minus 1. Now there is a first element and there is another element. First element will be considered as b of I and next element will be considered as b of I plus 1. The first position element considered as b of I, second position element is considered of b of I plus 1. Now if in the case of sorting b of I is greater than b of I plus 1, we have to sort the elements into an ascending order. So b of I should be less than b of I plus 1. Like first element should be smaller than the second element. But in this case, if the first element is greater than the second element, then we will mark the status as failure. So if here it is denoted as b of I is greater than b of I plus 1, then we will mark the status as failure and write the b into I is to n. And if such is the case, we will swap the elements and write the status as success. So for example, if we consider three elements like 4, 2 and 6. Now in this case 4, 2 and 6, we want to sort the element such that there should be output as 2, 4 and 6. In an output should be in an ascending order. So now what we will do, we will consider the first element, that is 4, and the second element, that is 2, as the two different elements. So the first element we will mark as b of I and the second element we will mark as b of I plus 1. So now here in this case 4 is greater than 2.